Welcome everyone to Advent of Code with Pandas. My name is Teddy Petru, and this is where I showcase advanced Pandas tricks. All right, here we are on day 8. This is our data, which is a grid of numbers. Each number represents a tree height. Our job is to find the number of trees that are visible from the outside of the grid. So to determine if a tree is visible, you need to look in multiple directions, and as long as it's visible from a single direction, then you'll count that tree as visible. All the trees on the edge are visible, right? Whether on the top, left, bottom, or right edge. So let's just take a tree like right here. The way to determine if it's visible is to look from the top. If all the trees are shorter from the top, it's visible. If all the trees to the left are shorter, it's visible from the left. So this one is visible from the top and the left. It is not visible from the right because you can see here there is a 4 over here. So you have to pretend like you're standing over here. And then you have to check if it's visible on the bottom. There's actually 99 rows of data, so you won't be able to determine just from this first whether it's visible or not. All right, so let's read in the data. We're not going to read in with CSV. We'll use FWF. This is a fixed file format, fixed width format. You do have to supply each width like this. So I know ahead of time there are 99 columns. This is going to be a list of 99 ones. So this will read it in one per column, one character per column, like this. So here's our tree, or a grid of trees. And the trick here is to take the cumulative max and then shift it down. So the cumulative max, this cumulative max method will just iteratively, for every column in here, so this is really cool, it actually does it per column wise, it'll report back the cumulative max up to that point. Right, so it's going to start at the top and do that. And I'm going to shift it down one. So it's really the cumulative max that it's seen from anywhere above it. Right, so this is the same thing as saying, out of all the trees that have come before it, what is the maximum that it has seen above it? So this is exactly what we want. We want the cumulative max of all the trees that have appeared above it. Shift just moves the data down one instead of having it the cumulative max at the current value. All right, so if we go down here, we don't need to read in the data again. To see if we're visible from the top, we're just going to see if DF, this is our current data, so is it greater than the cumulative max that's been shifted? I will fill in the missing values with -1, just because the lowest tree is 0 in height. This will ensure that these trees are always visible no matter what. Right? So we'll compare whatever this number is against -1, and that will always be true. All right, so let me go ahead and run this. This is actually the complete solution. But if we look at top, this will tell us whether that tree is visible. Right, so let's try to take one a little bit further in. So row 3, column 8, if we go back over here, row 3, column 8, we can see a 4. Everything is visible from the top. We're just checking the top. All right, so the others check in the other direction. You can do cumulative max going from left to right. That's what this does. From the bottom, we actually have to flip our data frame, take the cumulative max, and then flip it again so that you can't just say cumulative max, go from the bottom. By default, it always goes from top to bottom. So we just have to flip it twice. Everything else is the same. To check from the right, we have to flip it in the other direction. So we have to flip it this way and then do cumulative max. So they're all pretty much the same. The last thing is, so we get these 4 data frames that are all Booleans. We're just going to take or, whether or not we see them at all, right? So in either direction, this is the or operator. So only one of them has to be true. And this will again just return a true or false based on that. And then we're just going to sum up all of these values. First, it sums down the columns, and we sum the resulting series, and we get the answer like that. All right, so pretty cool trick with Pandas using cumulative max and shift to figure out this problem. If you enjoyed this trick, then you'll really love my book, Master Data Analysis with Python. There's over 500 exercises. There's many hours of video lessons, and there's also certification exams to prove that you have indeed mastered the material. All right, let's move on to the second part, which is actually quite a bit more difficult. And you can see here I put a barrier of 9s all the way around it in both the first and last rows and the first and last columns. So the goal here is to find out, say at any position, how many trees can you see from any position? So let's actually just take this 2 right here. So to determine whether you can see how many trees you can see, you get to look up, left, right, and down. And we're going to find the trees in each direction. So looking up, you can see 1, and then you hit the barrier of 9. You actually see this tree, so this is considered a viewable tree, so that's 2. Looking to the left, you can see all of the trees all the way to the barrier over here. Looking to the right, you can only see 1 tree, that's down here. Looking down, you can see 2 trees. All right, so once you get all 4 of those numbers, you multiply them together, and that'll be the score for that particular tree. And then your job is to find the maximum score. So, this actually took a while to figure out, but I'm just going to show sort of the crux of this, and that is in here. So what we're going to do here is, and I'm going to show it to you, this diff method. So this diff method basically just finds the difference between the current value and the one right above it. So you can see whether or not it is positive or negative. So let's take maybe this 3 and 8 position over here. So you can see it is 4 in the actual grid. So it has a difference, and the one before it is 0. So it is 4 greater than that. So that is, that is a positive result. Anything that is negative means you just cannot see that tree. So that sort of just ends it. And then you can do higher numbers like 2, that's 2 before it, right? So 2 before this 4 is 1. So you can see that right here has a difference of 1. So as long as it remains positive, as long as it remains positive, 1 after it consecutively remains positive, then you will know that you can still see more trees. Now what's cool is you can go in the other direction, so I can look past it using a negative diff like this. So I can look down. You can't actually see this because that is not there, but if I do df.head 10, you can see right there 3 and 8, it's a difference of 1. You can also change this to axis equal to 1, so this goes left to right instead of up and down. So that's how you can find the distances looking left or right. So you can change it to a positive or a negative, and it will do the same difference. All right, so we're going to use this diff method 4 different times. So the direction, and we're going to do it for all possible differences. So there could be up to 99 differences, right? So you could be at the very bottom, or really 98, I guess. So you're going to look for the difference between this one and the very top. So there'll be 99. So I'm going to go for all. I'm going to do all differences in all directions, right? So there's 4 different directions. This takes care of that, by multiplying it by the direction and then setting axis to either 0 or 1. So you can see there's a for loop out here that goes through. This will create 4 iterations for either looking above, below, right, or left. I'm going to keep the track of the score here. So I'm going to default everything to 1. So this is a data frame with the same shape as this. Everything is 1. And then what I'm going to do is for each direction, I'm going to do the diff 99 times, or really 98 times. And I'm going to determine if it is greater than 0. If it is, this is like an indicator. I'm going to keep track of these indicators, and I'm going to use the AND. So this is a Boolean. This is a data frame of all Booleans. So the AND, this is really how the trick for all of this is, the AND expression works out if it continuously is true, they all have to be true in order for the indicator to remain as true. So if there's anything that's negative, that means it's come to a tree that is its height or greater. and it will be false. And so the indicator will be false from then on out. Right. And then I'm just going to use this indicator to add to the score. So if it's 1, that means it's been true for all those directions that it has seen. And it'll keep accumulating the score, which I have set to be 1 at the beginning. So it'll always see at least one tree and then accumulate like that. So it's going to do that for all 4 data frames. I'm just going to append this score. So there'll be 4 final data frames. The end result is, let me just run this. So this is the score for looking above. So you can see here, actually, there's one that has 15 that we can visibly see in looking up. And then we just multiply all these data frames together to get the score for that particular tree. And then we want to find the max. So if we do this, you'll see that this is the score for all of them. Really, these should be set to 0, but since there's scores greater, the edge, I didn't really worry about that. And then just take the max of this entire data frame, and that is the answer. All right, so this one's pretty tricky. Couldn't directly use pandas. I had to use a couple of for loops here to iterate, but there's still a lot of pandas maneuvering inside of here. This is like sort of the main crux of it all. And pandas really does help out, minimize the amount of code and keep it, quite efficient. All right, so that's it for Advent of Code with Pandas Day 8.